Hello everyone and welcome to this Mobile World Live webinar as part of our Digital Unwrapped series. I'm Kavit Majithia, Managing News Editor of Mobile World Live, and I'm delighted to be your moderator for today's event. Over the next hour or so, we are going to be exploring the evolution of mobile technology as the industry moves from B5G to 6G standardization, with the next generation of networks expected to launch at the end of the decade. Now, it is very important to ensure technology development enables differentiated value on consumer devices and new types of device applications. But this is also dependent not only on communication technologies, but also computing and semiconductor process advancements. Delighted to say I am joined by 3 speakers today, 2 of which are from MediaTek. First, we have Dr. Mingxi Fan, who is Senior General Manager of Wireless Communication and Technology and System Design at MediaTek. Hi, Mingxi.
Hello. Thank you for having us here. Really appreciate it.
Great to have you. And second, we have Dr. Yikang Fu, who is Senior Director of Advanced Communication Technology Division, also from MediaTek. Hi, Yikang.
Hi. Yeah, thank you for inviting us.
And last but not least, we have Emmanuel Coulter, who is Senior Analyst of Network Sustainability and Innovation at GSMA Intelligence. Hey, Emmanuel.
Hello, Kavit. How are you?
Oh, good, thank you. So we'll begin with Emmanuel, who will give us an overview of the wider market before a presentation from our experts at MediaTek, and we will end with a short audience Q&A. To submit a question, please fill in the box on your screens, and we will do our best to answer the questions. And with that, I will hand over to Emmanuel, who will give us a lay of the land.
Thank you, Kavit, and good morning, good afternoon, good evening, wherever you are right now. In the next probably 10 minutes, I would like to give you a quick presentation, an overview, how do we see the evolution of different wireless technologies globally. My name is Emmanuel Coulter. I am a lead analyst at GSMA Intelligence, which is the analyst and consulting arm for GSMA. We provide research, report, forecast for the whole industry. And the following presentation will include some of our data, some of our forecasts, some of our surveys, and we would like to just give you a general overview how different wireless technologies are evolving globally. So end of 2024, we are at a multi-generational era where we still have 2G, 3G, 4G, and 5G at the same time. And on the other hand, 5G is not new right now. The first 5G commercial network was launched at the end of 2019, almost 5 years ago. And the first 5G network started to appear in higher scale at 2020. So it's not new. We have enough information to have some level of understanding about 5G and how the market, how users reacted to the launch of 5G. And on the other hand, it may sound very futuristic, but it's not. But 5G, after 5G, we expect to launch 6G, at the end of this decade, somewhere between 2029, 2030, and around. So it's not as far as it seems. And now on the slide, you can see a split of how GSMA Intelligence sees the number of users and their proportion of 2G, 3G, 4G, and 5G. So we don't expect 2G and 3G to disappear in the next 5 years. They're going to stay with us. And also 4G will have less relevance compared what we have today, the end of 2024. And on the other hand, we see that 5G is coming quicker, coming on a more rapid pace than any wireless technology before. Also, we currently have 265 operators in 140 market launch 5G. So compared to any previous generations, 5G is accelerating quicker. We also have 136 FWA launches in 66 markets. So we expect that by the end of this year, roughly subscriber growth forecast at 30% of 5G, and 5G connections will reach 2 billion, which is an enormous number. In general, we see four important number about 5G consumers and 5G according to our latest consumer research. So we had a survey where we asked a significant number of consumers in almost all regions about how satisfied they are with 5G and what do they expect. And we expect and we see that 75% of 5G consumers are satisfied with 5G and their 5G networks, which is a good news. It's an increase compared to 2021. So people are more satisfied with 5G than they have been at 2021. Also, we see that people willing to pay more for 5G. This shouldn't be a big news, but there were some worry about it. But it means that operators can actually these customers and monetize their 5G investments more than before. We see some regional differences, but the global average will be around 5%. We also see that users are interested about newer 5G use cases, and 30% of them is very or extremely find very or extremely appealing their 5G networks. And FWA, the reason why I highlighted this, this is one of the leading use case in many markets. Also, we see that it's easy to, and it's easier than expected to upsell with 5G and bundle with new services. And 5G is very, very regional. I think it's the most regional G compared to 2G, 3G, or 4G, because it used to be more like connecting people in the previous generations, connecting with voice calls, with 2G and messages, and also with data from the 3G era. But it was mostly about providing connectivity for people, which should be a homogeneous service, homogeneous goods. But with 5G, we see that this kind of diversity of use cases. So 5G is very different in different regions in Southeast Asia compared to the US or Western Europe or some part of Africa, for example. So 5G is more like not just connecting people, but also with connecting things and people at the same time. And as different regions have different kind of monetization perspective and different kind of needs, this is how 5G became very more colorful than any previous G. So if you have low fiber penetration in some countries, obviously FWA is a success story, such as in many parts of North America, in United States, or in South Africa, for example, or many parts in the UK, where you have limited fiber penetration. In other places, 5G could be extremely successful in terms of industrial use cases and private 5G, where this is the more like the focus. And also for entertainment consumer use cases, if sport events or concerts are more popular in that area, 5G can have a very strong consumer use case in this area. But in general, we see that consumers willing to pay more and likely to bundle 5G with new advanced services more. And also we reached the new era of devices with 5G. And I would like to highlight three areas here, and there is a lot of new technology at the first place. eSIM, foldable phones, many big breakthrough with the camera quality and camera capabilities, with battery quality, and also we see a lot of new technologies such as non-terrestrial networks and the use of satellite in hard-to-reach areas, or the use of millimeter waves in many use cases, such as in stadiums, the concept of cloud phone, and also many use cases for AR and VR. I'm not going to mention specifically AI here, but I believe, all aware how it's also disrupting devices and the capability of devices. So we see this kind of optimism around smartphone innovation. So after this kind of stalled phone design and phone technologies, we see this kind of hope and a lot of new innovation disrupting the smartphone market. We expect that this is going to continue in the 6G era in the following years and into the preparation of the 6G era. But we also see some risks, such as a backdrop in smartphone sales in the past few years in many areas, and also many impacts, many geopolitical or other issues, or COVID disrupting supply chain issues and causing supply chain issues, and this also impacts device manufacturers and also the whole supply chain. So this is the three most important trends how we see from the device end. We also would like to have and give you a forecast about 5G at 2030. So we did a survey and many forecasts about what do we expect in terms of 5G adoption, in terms of number of connections by 2030. We expect that this kind of consumer enthusiasm to continue. We expect that North America will lead in terms of 5G penetration with 90%, with 460 million 5G connections by 2030. After following Europe, Asia Pacific, and you can see the global average we expect will be around 56%, with in total 5.6 billion 5G connections, which is an increasing jump in terms of how other generation after 10 years. So this 5.6 billion will have a global, more than half of the population will be obviously covered with 5G connections. We expect that 5G advanced and 5G core deployments to improve and increase diversity further in the 5G design and how people use 5G. So we hear more and more deployment around 5G core. More operators in developing region is choosing 5G standalone. So we expect that this is going to improve how we can use and how will we use devices and add new functions and use cases. As mentioned, it's the quickest G, no question around that. Every G is reaching higher speed of adoption, and 5G is very popular in this sense, and people updating their 5G phones and willing to pay more. We expect that data traffic will continue being around 30% in the next years. There was some discussion around it's slowing down, but bigger screens and better cameras continue to increase data traffic, and also new IoT devices and new devices in general, and higher quality content will also increase data traffic in the next years. This regional 5G use case is expected to be as colorful as it is today, or even more. So in some area where obviously 5G and 5G mining, industrial mining is an extremely important industry, you will be able to deploy a 5G network and help those kind of industries further. While where banking or entertainment is more important, operators can focus on and satisfy those needs from their customers, both from the business and both from consumer side. And we expect NTN and satellite and in general non-terrestrial networks integrate into the current cellular networks and complement the current coverage provided by cellular networks. We expect that people are not going to obviously remove their existing cellular networks, but the importance of MTN and with the lower and lower prices of using and deploying and operating satellites will help to improve coverage in currently non-connected areas, in hard-to-reach areas. And I think my time is over right now, and thank you so much for your attention. I hope we'll have some questions in the Q&A session, and thanks again for your time, and hope you find it useful. Thank you.
Thank you, Emmanuel. That was a very insightful presentation. I'll now hand over to Mingxi, who will lead the presentation from MediaTek. Over to you, Mingxi.
Thank you, Kavit, again for your nice introduction, and also following the great presentation by Emmanuel. I think myself and Yikan are glad to be here to really share with you MediaTek's view really on the mobile technology evolution from B5G to 6G, really from a device perspective in this special time. So let's move to the next slide. And so from MediaTek engineering point of view, we have really been working very hard to make sure the 5G experience is really super for the end consumers. And really from optimization perspective, to look at high level, we really try to strive to ensure the users get good user experiences. That means we optimize the system performance from latency, data rate perspective, coverage, and also low power. And additionally, I think our work also focuses on, together with industry partners, to enable new use cases and applications so that there can be more values being generated for 5G, both basically from operator perspective and from basically the vendor perspective. And we'll go a little bit into what are the key optimizations that have gone into each area so far for 5G and then leading that forward. So next slide, if we look at basically the different evolutions on 5G and how MediaTek really has contributed there. Indeed, I think we started off with really try to ensure 5G has a good user experience that really have all the spectrum to be able to be used. So we started off with the world's first basically partnership with Ericsson and Verizon, enable FR1 plus FR2 dual connectivity, and then also drive to make sure the FR2 uplink 4cc to be enabled. And once that's done, then we want to really help network and the user to make sure capacity, data rate can be further optimized. Then we work with Nokia and T-Mobile, for example, enable the release 16 FR1 downlink 4cc carrier aggregation to drive a higher data rate. And then I think as basically carriers are looking to expand the coverage of 5G in a more efficient way, then we have been working with, for example, with Motorola and T-Mobile to enable basically the world's first release 16 PC 1.5 high power range to expand the coverage, as well as the FR1 uplink 2cc from the perspective. And then the next phase of 5G, once you have the coverage and data rate, kind of the elements are there, we move forward towards enable more use cases and more applications. So clearly we've been partnering, for example, with Samsung as on the world's first FR1 3TX, which is really kind of looking at the fixed wireless access scenario to optimize them. And move forward to make sure also we work together with ecosystem partners like Ericsson, Verizon, also Nokia, AT&T, to really enable release 17 RedCap. And for those, really I try to ensure the 5G now can penetrate into massive IoT consumer devices, right, beyond the smartphones, that can really bring benefits to more consumer devices beyond smartphone. So that's kind of how we're looking at so far things have been happening. So let me go through a little bit more of the optimization to see how we further enhance the user experiences. So from the next slide is basically in addition to the end-to-end ecosystem feature set enablement, MediaTek also have an in-modem AI technology we call MMAI, which is really try to use AI machine learning techniques to really do smart identification, for example, on traffic types, and also to identify different type of signal conditions to really ensure that in different type of environment, the battery saving in the devices can really be done efficiently, effectively, depending on traffic, how we switch basically the modem control on-off based on the traffic coming, and also to ensure that in the handover positions, conditions, as we detect users in different types of mode, we can really effectively reduce the latency and ensure a smooth handover experience. And the next slide really shows one example on how we do it beyond the many techniques. One example is we can really enable the devices just on the modem to be able to detect whether the user is in the airport or in the subway or high-speed train or in the hiking or in the elevator. And based on these type of situations, we can optimize basically the user experiences through frequent handovers or through kind of the non-regular type of the movements. And in those areas, ensure different applications like videos and gamings and the kind of the voices can really be smooth in those cases, and the power savings can really be efficient. So that's one example on really device-side AI that we have been driving to bring the user experiences, in addition to the end-to-end, basically the key standard features. And next slide, as we move forward, one more slide forward, is basically now we start to see that from a 5G perspective, one thing that's very significant for 5G that's different from previous generation is indeed to enable a wider device ecosystem beyond smartphone in IoT. And one of the most important IoT sector that 5G actually enable is the fixed wireless access. And that's why MediaTek has been working with key operator partners and infra vendors to really enable features on fixed wireless access that can bring better coverage and user experiences comparing to other alternative approaches. So on this slide, that they can see that by enable 3TX, basically on the 5G fixed wireless access, we can support a simultaneous uplink carrier aggregation and uplink MIMO, or also the FDD plus TDD MIMO to really enable a higher throughput, compared to other type of fixed wireless access solutions in the market. And the next slide is then beyond the fixed wireless access, we mentioned about the red cap. And yes, one benefit of bringing the red cap basically to the IoT devices versus the status quo leveraging smartphone IoT is the red cap basically product from MediaTek utilizing the basically the appropriate bandwidth and the characteristics. We can really bring down the power consumption significantly compared to the regular eMBB 5G modems, and thereby really enable the massive IoT devices that needs 5G connection in form factors like wearables or data dongles or kind of tracking devices for these type of things to really be a lot more battery and power efficient. And that's how we try to really see that's very important to enable 5G in a wide area and a wide array of IoT devices. Yeah, and working together with industry. So now let's come into the next slide. Now one more thing, even beyond the regular IoT devices, one thing that's really defining moment for 5G is it has expanded capability, connection capability beyond terrestrial network to NTN. And the MediaTek was there together with ecosystem partners at the front line to drive the standardization as well as drive the technology adoption, basically through demos and industrial launch. So basically this NTN in 5G so far has really, grossly speaking, two versions. One is called narrowband IoTN, or people call IoT NTN, and which is really for kind of the satellite messaging type services in a narrowband IoT type of the waveform, right? And then the other version is called NI NTN, which can operate in a wider bandwidth depending on the available spectrum, right? So what MediaTek did is, on the left, basically we have driven the IoT NTN first commercialization with our MT6825 chipset with bullet devices, and then move further to really enable the satellite messaging in the industry very early. And then we have also demonstrated a capability to really do satellite streaming and voices through wider bandwidth over L and S bands through our NTN test chip, which is also we have capability in the product as well. And also we have demonstrated just in this MWC, Mobile World Congress, that we can expand NTN to 50 megahertz or more using KU bands from that perspective, and really enable that, paving the way to release 19 NR NTN to show that really NTN application can also be applied to automotive and other IoT type of verticals. So that's also very important beyond the terrestrial type of network. And so now if we pause here, so that's all things we have done up to release 17. Now from release 18 perspective, again, we are, and so please move to next slide. Now basically we are really now working actively with our industry partners together to, in the release 18 standardization, now move to release 19, right? And then all paving all the way towards to be ready to the release 21, which will be the first ever industry 6G standard. So before talking about the 6G, release 18, 19, and 20 is what we call kind of the transition 5G standards or the 5G advanced standards. And really, if you look at the feature there are two categories of features. One category is really the continued enhancement to the 5G user experiences, right? Like the CA enhancement, faster mobility, network energy saving, to continue to ensure the 5G brings good performance and a good battery savings to the users. And the second set is what we call a warm-up for 6G, which is really because 6G will be the native AI interfaces. So there's early AI machine learning type of standard to be used in CSI beam management, for example, for release 19, and may expand further to release 20 with mobility. And also, for example, we may be looking at the spectrum of FR3 early planning in release 20. So these are the categorization of generally the features there. So now let's look at a little bit more of these beyond 5G features by example to get the flavor of them. All right, then next slide, please. So the first set of flavor is, as I mentioned, these are continuous improvement to the throughput and user experiences in 5G. So for example, in release 18, there's the multi-carrier CA enhancement to use a single DCI to cover the multiple cell scheduling. And in that case, basically, you really optimize and saving the overhead, and that leads to a certain throughput gain, as shown here on the slides. And further, there's also the mechanism to enable 2x PU SDH uplink 2T switching, so that really you can aggregate more slots across bands, and that leads to a certain uplink throughput gain as well. And the next slide, and basically one thing that's very important in user experience for the mobile, no matter where you are, is really the mobility and handover. So based on the release 15 in the RRC-based handover, I think today, if you start with the measurement report, then go through the handover command, then do configuration and sync, the total handover in this 5G experience is really about 75 milliseconds across different cells. Now, of course, in release 16, you can use DAPS handover, the dual active stack handover to significantly optimize that, but the expense there is the mobile kind of has a more implementation burden and have more power drain. So basically in the release 18 perspective, I think MediaTek has been working with industry partner together to really introduce basically the lower layer 1, layer 2 triggered mobility so that the downlink and uplink sync can happen earlier. And that by itself actually can enable basically the handover delay to be reduced from 75 milliseconds all the way down to 20 milliseconds, and also reduce the data interruption ratio compared to the release 15 baseline, as well as reduce the handover failure rate as shown here on this particular slide. So that's an example for the user experience improvement. And then the next slide is really, I think, one very kind of a reasonable progression, I think, on the evolution is in addition to the network side of massive MIMO. From device perspective, I think with the foldable phones coming now, I think there are rooms potentially for more receiver antennas per band. So the 6th receiver antenna in smartphones is really being discussed now as a part of the progression forward to be standardized in 3GPP and to be applied to commercial devices, so that you really have a higher, basically better coverage that leads to a higher average throughput, especially for users at the cell edge. And then also for CPE devices, which is really have a larger form factor, you can enable 8 receive antennas. So now one thing to differentiate here that we really see is more receive antennas typically, of course you can do more MIMO layers to enhance the peak throughput, but honestly I think most of the gains here are being captured by larger number of receive antennas. As you see on the figure in the left, basically what you see is really between kind of the 8 layer and base 4 layers, the throughput of ARX is actually not that different in a sense. And from average, and on the right hand side, really for the 6RX, really majority gains are really comes in with 6 receive antenna and 4 layers from that perspective. So we believe that would actually be a very good starting point to just have the receive antennas bring in the receive diversity coverage gain for users. And then going to next slide, please. And so next slide is, now next we're going to talk a little bit about the early prep towards the framework towards for 6G, right? So one thing that the release 19 has introduced is really an AI machine learning framework where basically the devices can really learn the environment, and therefore by learning the environment, ideally you could actually, for example, in the case of CSI prediction perspective, right, by able to really predict the channel better, then in this case you can allow the network to send you less training signals, and thereby you really save on the overhead overall. And this technique, of course, I think industry, multiple vendors have demonstrated, and there's similar ideas for beam management. And for location-based positioning services, it will also enable a fingerprint-based type of positioning to really enable the mobile to truly to be able to sense the environment for more accurate location. But one thing that's very important that's been standardized and that's been discussed in standards, which is still yet to come to a clear conclusion, is really kind of from a data collection perspective that's necessary to train the model and to really update the user throughput. You know, how is that managed? There's something called a life cycle management. There are various options. One is the data can be collected by the UE, managed by the UE's own server, right? And of course, from that perspective, we have to address we have to get consent from user and address concern privacy. On the other hand, is basically the data collection can be done in an MDT-like fashion with network control, where the security and all of that can be managed by the operator. And through that, there can be less concerns on the privacy and consent. But at the same time, to be able to enable kind of the end-to-end, the secure network management from the data collection perspective. So these options are definitely being discussed right now in the standards. And from MediaTek perspective, we would have capability to support both, but we would also support from a carrier perspective the MDT-like data collection, all right? So and then next slide is really, I think, again, I think I mentioned before that you know, for the NR-NTN, right, so far we have been looking at LS band, which is about 5 megahertz bandwidth, which we have demonstrated in last year's MWC. But in this year's MWC, we have demonstrated this NR-NTN over KU band, which is a subject for release 19 to look at for standardization. And the perspective is we have demonstrated that by over 50 megahertz of bandwidth, as shown here on the table in the lower right, we can actually really achieving significant streaming data rate really to the users and really and the stream and in a good video quality, really and really on the mounted and with an antenna panel mounted on top of vehicle to really overcome not just the Doppler but also the beam management over the fast satellite type of movement. And the technologies readily can be supported by already the techniques here. And if industry partners need to enable, we can work together with industry partners to enable them. Okay, so that's really kind of more advanced for NR-NTN to consider basically to expand the capability further into KU band, which is also potential candidate band also for 6G as well. And so next, I think we're going to transition now to go from 5G to 6G. And I think you know, I'm going to hand over the presentation to my colleague, Yikang, for the next part. Yeah. So he's our man for 6G.
Yeah, thank you, Ming-Chi, for the excellent summary on the state of the 5G and B5G technology. So here I'm going to share with you the MediaTek's view on what is coming next for the new generation. Before we talk about 6G, I think you can imagine it, what is your understanding on the difference between 1G, 2G, 3G, 4G, and 5G. And I see many people will just have a very straightforward idea. Okay, we got 10 times the data rate or 10 times capacity for every generation. And that is quite probably the most straightforward people's impression. But some people may have some further like idea. From 1G to 2G is like from analog to digital, like a phone call. And then the 2G to 3G is from voice to data. 3G to 4G is from internet, to the video streaming. 4G to 5G is mobile broadband. And people start wondering, then for 5G we already have all the use case supported. Then what comes beyond 5G? So from MediaTek's perspective, we believe from 5G to 6G, it might be the very important transition when we transmit from bit to token. For the bit, it's like for between the human to human communication, we are digitizing all the information in the bit. But when we have AI talk to each other, actually the information being exchanged is actually the token. So if you take the token and the AI operation into consideration, the potential data rate requirement for 6G might be actually much higher. For example, if it is a device pen collaborative model training, it may take even like 100 gigabits per second data rate requirement for the model exchange. And even for the inference, for the AI, your AI agent need to get more information from the cloud. In order to answer your question, it may require 10 to 100 megabits per second data rate. And of course, we still have more use case already there, like immersive communication from AR, XR. It could take not just 100 megabits per second, but it also requires very short latency, like 10 milliseconds. And all in all, so right now people already forecast all the mobile traffic will keep growing. I think people envision there could be 4 times the mobile data increase from now on to 2030. But people are also speculating that if the AI application getting more and more popular, maybe the real data traffic growth may be even higher than this one. So if we go to next page. So when we envision the 6G era, we do believe the ubiquitous AI could be the most important application for the 6G business case. But there could be also quite certain challenging that we need to overcome, not just from communication network, but also from the whole infrastructure perspective. For example, how the AI computing and storage are to be offloaded, whether the processing is everything on device or is server-side processing, or is kind of the integration among these two, like hybrid or distributed computing. This is one area people are still investigating. And then there could be also different application people are developing. For example, there could be a different device type and different size of the large language model. So right now, different variants of application are people exploring. For example, now you have a ChatGPT, very powerful, everything on the cloud. He can answer almost everything for you. And even the large language model can generate a very powerful, a very fancy photo or even video for you using all the resources on the internet and all the computing resources on the cloud. But on the other hand, we also have a lot of device type. For example, you have not just your smartphone, but you also have your wearable device. And there could be also other AI application. For example, in all the movies, you have ever saw this kind of a personal AI agent, just like someone listen to you every day. He can find all the resources to support you. But it is obvious that not every device have a sufficient computing resource to answer all the questions you are asking. So there could be some small AI model on the edge side, but also in cooperation with the big AI model in the cloud side. But in order to connecting that, the AI-assisted modem is actually the key to bring them together. And in addition to that, there could be a power consumption challenging. People are already envisioning a new power plant is needed. So in terms of the infrastructure design, we also need to look into what is the how much milliwatts we are needed to transmit every token, and what is the spectral efficiency when we transmit the token. And also the privacy is always the most important thing from consumer perspective. Of course, we can do everything on the cloud, but you always have your personal data on the device you may not want to share with the cloud. Then how to divide, how to balance between the service and your privacy. And at the end, this service capacity and coverage, then that goes to the next page on how the communication infrastructure need to be upgraded in order to support ubiquitous AI application. If we can go to the next page. So on this page, it shows you we already on the right, I think right now we have a cloud-based AI application. It's already popular. It's actually bringing all the communication device, trying to connect to the cloud and enable this ChatGPT-like application. And there is also quite certain effort trying to deploy the AI application to the network edge, either to the core network or to the RAM. But today, this year, I think also including the latest MediaTek smartphone SoC product, there is also a device AI getting popular. So there are also some kind of AI application like a translator or some kind of a personal agent to handle all your calendar and all your like a restaurant reservation requests. And that can happen on the device. And we are also envisioning, because every single person, you have a multiple device that belongs to you. And we are envisioning one of the vision of our MediaTek CG is that your personal device can actually work together to form a device cloud. And we are envisioning eventually this personal device cloud can also be part of the overall infrastructure resource. And all the cloud vendor and the network vendor, they can eventually see how to distribute the AI application and the computing resource from cloud, RAN, and even to the personal device. So if we keep moving forward, then in addition to the computing resource distribution and leverage, and the communication infrastructure also need to be upgraded in order to support the increasing demand on the AI application. So the first one is from air interface perspective. Here is some selective research result we would like to share with you. As you can see, the operator spectrum deployed today is more and more fragmented, from the below 1 gigahertz, 2 gigahertz, and even to the C-band, a millimeter wave, and now we are also having the FR3. So when we define the carrier aggregation in the LTE RIS 10, then we simply add another carrier as another cell. But eventually, operator found that now we have a lot of, a huge number of CA will create a huge number of the overhead. So one of the concepts we believe that 6G need to consider is that eventually we need to redefine the mapping between the logical cell and the physical spectrum resource. For example, one cell can control the multiple component carrier resource across a wide spectrum. And next one is we call that ambient intelligence, and that is what we also mentioned in the previous page. Eventually, the mobile edge cloud could be the personal cloud and the RAN cloud integration. It depends on how fast the latency people are required and how the loading and computing resources are available. And in addition to that, for the satellite communication, people keep asking what is the difference between 5G satellite communication and 6G. And we believe one important area is this NTN spectrum sharing. Because right now, because the legacy proprietary satellite communication technology doesn't talk to the cellular network, so we can always use the worst case planning to do the interference avoidance or do the coexistence. But if both the cellular and the terrestrial network are using the same protocol and radio interface, actually there could be quite certain interference mitigation approach being deployed. Then eventually we can open up the precious spectrum resource to be shared between cellular and the spectrum and the satellite industry. And this is already happening in the US, and we expect the regulation will keep discussing in the 6G era. And also this massive MIMO beamforming is also critical for the powerful satellite to the beam steering to the ultimate user experience on the ground. And the more important thing is the sustainability, because right now the electricity bill is already a huge portion of the operator OPEX. And on top of that, we also noticed the global regulation. There is an initiative on this a carbon tax, carbon fee. So eventually, all the electricity consumption will have additional expense from the carbon perspective. Therefore, we believe trying to adopt more and more renewable energy to reduce the carbon footprint will be very important for the future mobile network. But in order to do that, in the network, all the network element, I need to be aware of what is the electricity source it is using. So eventually, we need to consider not just energy per bit, but also the carbon per bit. So moving forward to next page. So now go back to the fundamental challenge for the mobile industry, the spectrum. So as Mingxi just mentioned, the 6G FR3 spectrum is now, there are several challenges in different regions. For example, from 7 to 8 gigahertz, especially in the US, it is a promising spectrum as a 6G candidate. But over here, there is ultra-wideband coexistence problem. And there might also be a consideration from Wi-Fi and satellite perspective. So how to well coexist the cellular technology and the ultra-wideband could be quite critical to open up the spectrum resource here. And next one is from 10 to 10.5 gigahertz. There is also the 15 satellite interference here that we need to protect if we want to open up the FR3 spectrum here for the cellular use. And there is also a big portion around 12 to 13 gigahertz. Right now, in some countries, that is already open up for the LEO satellite broadband application. And over here, there is also like in US, like from 12.7, 13.22. There is also the repurposing discussion under consideration. But if we want to open up the spectrum here for the cellular use, then the coexistence with satellite will be challenging. And that also brings a motivation whether we can turn the harmful interference become the desired signal if we can share the spectrum across satellite and the cellular. And the upper part, there is also a new spectrum under the WRC27 consideration from 14.5 to 15.35. But over here, there is also a challenge from deployment and the link budget perspective because the operator doesn't really want to reduce the inter-site distance. Then in order to close the link budget gap, then also there is additional antenna might be required from the base station deployment. And in order to do that, you need to increase RU size from the base station side. But there could be also another way to enhance that is from the device side, from CPE or automotive side. UE beamforming is also possible. That can make the deployment trade-off become more balanced. So moving forward, from 6G, we think it is also important to consider there could be quite a wide variety of the device type. And in the 5G, we used to have this kind of a discussion on whether we should have a minimum set of the UE capability. But unfortunately, that didn't really happen. But we think that is important moving forward to the 6G. So our vision is that we need to have a well-agreed, we call that 6G nucleus, that define the minimum basic requirement of the device capability. For example, in the FR1, it can support like from 20 to 50 megahertz. If we want to consider FR3 or FR2, then we can support the basic like 50 to 100 megahertz. Then on top of that, you can have a very different kind of a device application, like from different form factor. If you want to have a wearable, maybe you want to keep that as simple, but very small. But if you want to put that as CPE, we want to scale out to support a wider bandwidth and then higher data rate. And then maybe you want to go further to have a carrier aggregation and you have a multi-band support. But all in all, we want to make sure there could be a very fundamental core 6G nucleus as a basic device requirement be defined. And then make the 6G device type and category become scalable on top of that. Then let's talk about next page. It's about the Envision timeline. As you may already see, the 3GPP is going to kick off the 6G project next year. So it is critical for March 2025. There could be the first 6G workshop in 3GPP. And then the 6G the study item will kick off and then move into the work item. So everyone expect around the end of 2028, we will have the first version of the 6G standard. And then onward on the 2029, 2030, that you will see the device and all the prototype being available like in the field. And MediaTek actually have been prepared a lot on the 6G R&D. If you go to next page. So in the past few years, we have been working with a worldwide 6G initiative. For example, in the US, we are the founding member of the Next G Alliance. And in Europe, we are also the advisory board member of the X2. And in China, we are also participating in this IMT 2030 promotion group. And like in Singapore, like in Taiwan, and also like in India. Also, all the regional initiative in the past few years, we are being part of that, contributing our vision and helping to consolidate the worldwide 6G consensus. And from next year, now we are quite exciting, waiting for the 3GPP kickoff the war. Then we hope to converge the worldwide 6G vision, become a unified 6G standard, and to create another successful story for mobile cellular technology. And we are showing some number here. We have been working with many universities and published a lot of white paper, academic paper. We are doing the Mobile World Congress demonstration. Yeah, MediaTek has been actively investing on the 6G R&D in the past few years. And from now on, we are also actively contributing to the 6G standardization. So the next page, I'll try to summarize the MediaTek 6G story and just echo to what Mingxi has been presented as what MediaTek has been doing for 5G. We want to enable a healthy and a user-centric device ecosystem from 5G and also all the way to the 6G. So we believe the consumer market will continue to be a focal point of the new AI revolution from 5G also all the way to the 6G. And we believe the mobile device will again play the central role, leveraging the AI power to ease and enrich all the human life, like what you already experienced today. And eventually, from the 6G technology perspective, we believe that it will provide a dependable enabler for the good user experience and with a variety of the personal devices and with enhancement over the capacity and high data rate along with the low latency and integrated computing and storage sharing, ubiquitous coverage, and also the seamless mobility. And at the meantime, we want to enable all the diversity of the device ecosystem while having the economy of scale that brings to the commoditized and consumer market. And eventually, as always, the privacy is always the most important thing in the MediaTek culture. So hope that can conclude the 6G vision for MediaTek and connecting with all the 5G successful story that introduced by Mingxi.
Yeah, so Kevin, I think now we go back to you.
Thank you, Mingxi and Yikang, for that very insightful presentation. We now have got some time for some questions. There is still time to ask a question, so just submit a question in the box and we will try our best to answer it. We'll start with this one. It's been 18 months since MediaTek launched its 5G NTN chipset. How is the satellite market progressing?
Okay, so maybe you want to take that.
Yeah. Thank you for the good question. Yeah, indeed, MediaTek launched the industry-leading MT2685-based commercial product supporting the narrowband NTN, which is suitable for the short message service. And we are ahead of any other such service in the world. And we have seen the growing interest in the smartphone direct access to satellite across US, Europe, and even China market. Right now, we can see the satellite emergency message service is gradually becoming the basic requirement for the high-end smartphone. And on top of that, we also see the other messaging kind of a service, such as text message, location sharing, or even like a tracking service, is now also getting more and more like attractive on the smartphone device. So we can see that it is gradually being enabled in the smartphone market, and gradually it will also be extended to the IoT devices. So as we can see, the market keeps growing. So we think this standard NTN solution is actually quite critical. It plays an important role to ensure the interoperability across different devices and also the satellite constellation. This will be the very essential way to maximize the economy of scale.
And just staying with NTN for a moment, what difference will NR NTN make, and when do you expect that standard to launch?
Yeah, thank you for the question. It's a good question. So from standard perspective, the NR NTN can support larger bandwidth for higher data rate and broader application, especially in the place where the terrestrial coverage is limited. So MediaTek, we have demonstrated last year in the Mobile World Congress 2023, showing the video call over the smartphone is actually feasible using our NR NTN test chip. So our demonstration was using the 5 MHz bandwidth over the S-band, and we can achieve up to 7 megabits per second in the downlink, and uplink we can run several hundreds bits per second data rate. By doing that, we can enable not just voice, but also the video call. And furthermore, in 2024 Mobile World Congress, we further showed that we can even achieve more than 100 megabits per second data rate using 50 megabits hertz bandwidth over the KU band NR NTN. By demonstrating that this is also the way that 3GPP now kick off the KU band NR NTN work item in the RIS 19. And the key technology behind that is requiring the beamforming technology on the terminal side. And we believe that this could be suitable for automotive use case for satellite broadband everywhere. And now we are waiting for satellite operator to deploy the NRNTN capable satellite to enable such new application in the market space.
Great. And we've got one on 5G Advanced here. As 5G Advanced equipment is now being deployed in some regions, what new features do we have to look forward to?
Okay, so that's actually a very good question. I think one thing we have to look at for 5G deployments at this point, from our knowledge, I think quite a bit of release 16 or especially 17 type of features are still yet to be rolled out or still in the trial stage. So, and we feel that from what we have seen from the market, many of these features to be rolled out will be some ones of practical benefit to the coverage and the network capacity increase, and also device battery power savings from the perspective. So, for example, I think some of the things like including some of the enhancement to MIMOs, and also things like L4S for certain applications enablement, and also some of the release 16, 17 low power features. They're yet to be deployed, and we feel that they should really come out first, and that's really kind of be in the planning. Now, one thing that's also very important in the near term was also spreading 5G more effectively to a wider scale of IoT, which is the RedCap feature. And we have seen some early commercializations, and definitely I think those will propagate even further. Now, after that batch, it will be the 5G advanced type of rollout. But I think the direction should also be similar. It's going to be really to be kind of a user data rate enhancement, as well as a capacity enhancement. So, for example, I think how to really enable kind of higher data rate downlink, especially in the FR1 spectrum regions using 1024 QAM, and really up to 1 gigabit per second uplink via TX switching. That's really one set of enhancement becoming. And then massive MIMO, with the ports up to 24 even further to enhance the network capacity through MU MIMO, that can be effective. And application enablement via, for example, layered QoS for XR-like traffic is also under ecosystem trials. And I think then further, I think practical features like LTM and energy saving, both for network and devices, are also the important ones to consider as well. Yeah.
And moving from 5G Advanced to 6G, how will 6G be different from 5G, and what defines it as the sixth generation?
Yeah, so one thing that's very important is every generation, as Yikan has actually mentioned in the slide. I think really everyone's asking, what is the difference in 6G in terms that you can enable the consumers and from killer application? Well, one thing we really have to say is really, I think, number one, I think the 6G will definitely be a technology, one generation beyond 5G to really enhance the network capacity to address growing user data demand, which really doubles every 3 years, still roughly. And that really start to come, and that really, with all the AI applications, I think the data rate there will even rise further. So really practically, I think how 6G can really enhance the capacity and also provide significant benefits using the new spectrum like FR3 to enable the practical user experience. That's actually very important to start from day one, right? So I think, of course, people can say, does that really define a new generation of technology? Well, you can call this 6G or kind of 5G Advanced or 5G Advanced Plus, but really I think the kind of capacity enhancement as well as basically to enable basically the new spectrum is something that's very important. And then further on, I think really basically for the 6G capability to introduce in addition to 5G that we see today is really another slide that you can have gone through, which is one that really integrates communication, computing, and sensing all together. And all of them done through a unified over-the-air spectrum. So from that perspective, basically you can, for example, have a device cloud securely managed by network to really orchestrating the AI-based computing applications across things like smart glasses, wearables, and home CPEs, and also device, and also like smartphones, all of that, and to have compute offloaded as well as by the network edge, and have that computing plane being pushed down lower layer into the really the air interface domain for this to be more better latency and better security, right, towards like a personal or network edge distributed device cloud. So that's the second thing. And the third aspect that I think can be different is also the additional emphasis on the energy efficiency, and basically I would say carbon zero type of communication, right? So basically like in addition to really driving a very low power type of communication, there will be also, for example, be labels like QoS attached to different traffic streams that are labeled with the energy source. So basically the traffic types with basically the more environmental friendly energy source can be prioritized, and they encourage us to make the communication to be more sustainable. And that's also something that's very important for these areas. Yeah.
That makes sense. And we've got time for one more question. How much is MediaTek involved in the 6G standardization process?
Okay, maybe I'll go take that.
Yeah, thank you. Yeah, it is an important question. I think 6G standardization project has not been officially kick off yet in the industry range. Of course, some study has been initiated, but the MediaTek has been a leading contributor to the standardization of 5G in 3P for a long time. So paving the way to leading a position on the market, as well as focusing on some practical end-to-end features that truly benefit to the consumer. So there is a lot of 5G feature, but MediaTek always focus on the really useful and eventually that could be commercialized feature. That is our track record. So with a strong technology know-how, product focus, and world-class research, so we have been preparing for 6G technology for a few years now, from working with the university and also our in-house research engineer and experts. So we have actively participated in the key regional forums such as the Next G Alliance in the US, IMT 2030 in China, and also in the Hexa X2 in Europe, as I just mentioned in earlier slides. So among those a lot of effort, so we have also been actively working with ecosystem partner to set the foundations of the 6G standardization toward the one global standard in the world via the 3GPP. We think that is a key to ensure the commercial readiness by 2030. So we don't want any fragmentation on the 6G standard. So we're now putting the final touch on our overall 6G design ahead of the 3P 6G workshop, which will take place in March 2025. And we are truly excited with the technical discussion which is coming soon. So we are also actively engaging and will continue to engage with all our ecosystem partners to set a foundation framework together with early 3GPP discussion throughout the standardization phase. So we are quite looking forward to that. So it is coming soon.
Yeah, so basically one more thing just to add. I think from MediaTek perspective, we are really kind of here to emphasize the importance of global ecosystem partnership. So we are here really to develop the 6G technology together through standardization, through global partners.
Well, I think that's a great place to wrap up. Thank you so much to our speakers today. Thank you, Emmanuel, and thank you for the team at MediaTek. And thank you to our audience for taking part as well. If we didn't get to answer your question, someone from the team will get back to you shortly. And if you missed any of the content, it will be available on demand. Thanks again, and we'll see you next time.
Okay, thank you so much. Really appreciate it.
Thank you very much.